Good morning everyone. Today we are discussing about inverse kinematic of 3 degrees of freedom in 2 dimension for the subject ORS 351 Foundation of Robotics. After completing this presentation you must understand the concept of inverse kinematics of 3 degrees of freedom in 2 dimensional. Previously we discussed about the forward kinematics of 3 degrees of freedom with 2 dimension and forward and inverse kinematics of for 2 degrees of freedom with 2 dimension. Same as that inverse kinematics of 2 degrees of freedom, we also discuss inverse kinematics for 3 degrees of freedom. So, if from the figure it is clear that for 3 degrees of freedom we have an extra link, that is link 1, link 2 and link 3. So here we consider the angle for link 1 is theta 1 and the angle for link 2 is theta 1 plus theta 2 and angle for link 3 equal to theta 1 plus theta 2. L1 is the length of link 1, L2 is the length of link 3 and L3 is the length of L1 is the length of link 1, L2 is the length of link 2 and L3 is the length of link 3. For inverse kinematics, you have to find the values for theta 1 and theta 2 from the Cartesian parameter x and y. So, from the inverse kinematics of 2D manipulator, we know that theta 2 equal to what? Cos inverse of x square plus y square minus L1 square minus L2 square the whole divided by 2L1 L2. This we already derived for 2 degrees of freedom. This is also the theta 2 value for the 3D manipulator. Similarly, theta 1 equal to tan inverse of y of L1 plus L2 cos theta 2 minus x into L2 sin theta 2 divided by x into L1 plus L2 cos theta 2 plus y L2 sin theta 2. So, from by solving the equation 1 and 2 from x and y, we get the values for theta 1 and theta 2. When defining the position of the end of the arm, we use x, y and psi. Psi is the orientation angle for the wrist and the rotation position about z axis. So, from that we have to find what? Theta 1 and theta 2. For 3 degrees of freedom, the value of psi equal to theta 1 plus theta 2 plus theta 3. Here we put sine in theta 1, tan inverse in terms of sine theta 1, we have to put that equation. After that, in terms of cos theta 1, we have to put the equation b. So, we have to derive the final equation. So, that's all about inverse kinematics of 3 degrees of freedom in 2D manipulator. Hope all of you understand this concept. Thank you.